Not all physical phenomena are readily apparent to the naked eye. Some of these phenomena only become apparent under certain conditions. Others are always affecting the world around us but cannot be observed by us. Length contraction is one that is always working but we don't necessarily notice it. When an object is moving, its length shrinks in the same direction as its velocity. Length contraction is the phenomenon of a decrease in length of an object as measured by an observer who is traveling at any known zero speed relative to the object. I would like to explain a very interesting paradox based on the length contraction. As you can see in the image up here, the paradox considers a table with a gap in it and a bar that is making its way towards the gap. We can analyze the paradox from two points of view of two observers. The first one, which we are going to call A, is the point of view of the person that is standing still relative to the table. The second one, which we are going to call B, is the point of view of the person that moves with the same velocity and direction as the bar. This observer is at rest relative to the bar, but is moving relative to the table. We can define that in case A, the bar has speed plus v, therefore the bar is affected by length contraction and is supposed to fall into the hole. In case B, the table has speed minus v, therefore the gap in the table is supposed to be affected by length contraction and the bar will not fall in the gap. We can consider it a paradox as we assume that there is only one version of reality and that the bar either falls through or it doesn't. The right opinion is the one of observer A. We can see from that picture that according to A, the bar falls through the gap, which is bigger than the bar, as the bar is affected by length contraction. The only way you can consider that the bar falls in the hole in case B is that assuming, as you can see in the picture, that the bar suffers a folding of its front part that makes the whole bar falls through the gap. From this paradox, you can also see that the concept of rigid body is defined with difficulty in relativity. As you can understand from this paradox, a body can't be defined as rigid in all the frames of its motion. When measuring a body's length in the x direction, two events happen simultaneously, but separately in the space: the position at the beginning and the end of the bar. Two simultaneous events but separated in space in an inertial frame are not simultaneous in another inertial frame. This causes the phenomenon of length contraction, therefore moving objects are shorter. From a quantitative point of view, the effect of length contraction versus relative velocity of the moving object is as represented in the graph above, where in the equation above, L0 represents the length of the object in its rest frame. A more in-depth and technical description of the topic of length contraction and of the paradox just discussed can be found in the scientific paper above. The link is also available for this paper.